Hello, let's try again. I tried just a minute ago and I couldn't stream because my transcoding server wasn't up, so I hope it's working now. Let's check again. Okay. It seems like it's now working fine. Yeah, it's working fine now. So, back to our thing. Last day we did some camera logic, but still couldn't move it around, and it would be interesting to be able to move it. So, as to do that, you'll have to fix first our input logic, which is not working fine. You see, right now we're being called every single time our mouse moves, and that's not exactly one time per tick. It's rather, well, I don't even know how many times, that maybe 1, 2, 3, I don't know. So we're going to change that, and we're going to manually ask for keys to glfw instead of setting a callback. So let's go with it. Must open our game too, into our main. Okay, first of all, we no longer have this callback, and we no longer need this. Let me double check. No, well, we may save this for later, but we don't really need it. So, okay. Our main must neither be bind here, and to our game instead should have a method called handle mouse. No, we'll say handle input. Okay. Fine, let's go to our game. This no longer exists, so let's say it's void game handle input void, which should take no parameters.
The only thing that I ever really loved in my life is house music.
Yeah, no parameters at all.
Ever made me sneak out
I should instead ask for window for some mouse coordinates. So we'll be doing kit.
back when I was
Let's see.
17.
We'll be doing it as an inline method,
The only thing that kept me out all night was house music.
and it will be void get mouse. Let's say get mouse,
Coming home in the morning,
and it will ask for INT8
combination.
buttons. Oops, sorry.
The years go by.
INT8 buttons,
Places
integral position,
the music
and
stayed
that's all.
the same. In my heart,
I believe it's integral.
it's about
We'll see now. It may not be integral, so
it's about the bass.
let's simply call it.
In my heart, it's always about closing my eyes and listening to the house music. Take
Get mouse, it's fine. Oh, let me say on Twitter, we're online. Just in case somebody sees it.
I don't care what anyone says.
Yeah, let me write it.
I don't want to listen to anything else.
Streaming on
Deep house,
Twitch.
house.
Just a moment, please. And game back. So that's fine, okay. Go to our theme. So our mouse requires us, well, we did need it to be passed a reference, as we will be setting the value here. Let's copy this over. And I said let's save this for later. That will come handy. And see, it will come handy. Up to here. And none of this is useful. So, oh sorry, I didn't want to debug.
They always have
Okay,
something
here
I don't want to describe it.
mouse is buttons course. It's not compiling as there's some code wrong. This is no longer needed,
But to me, it's all about house.
and we'll be getting
Feeling really good
cursor of window.
that you're in a place listening to something.
This is just to know if you have or not
Change your soul.
pressed right and left.
House music has made me cry.
And we now need to get our mouse position, which will be get by
Really, really low.
glfw
Times when I
get
couldn't
cursor pause. That's it. window. It requires an expose and by pose
And house music is
that will
lifted.
call like this.
It's encouraged
Oh,
me to
it's not an INT that we want? No, it requires this
everything
double.
I feel about house music is good.
So let's give him double. Sorry, here, double, double. Okay, so far so good. What else?
Anyone says,
We must tell ZFW to save
anything else.
all input until we actually request it to. Otherwise, it could simply tell us that never nothing pressed at all. So let's call it key persistence, and they call it ZFW set input mode. It requires a window again. A mode must be one of GLF cursor or GLF sticky keys. So we'll call it we'll call it GLFW sticky keys, and that be GL2 and GLFW set cursor. I thought it was cursor mode. It's not, so oh, it's so here it's GLFW sticky mouse buttons. That's kind of a weird name for a variable, but that's it. So this will prevent keys from being flagged as not pressed until we actually get them. That's fine, get mouse, it's implemented. So back to our game, handle input. With let's make it even better. As we know, we have that mouse fixed function which sets our mouse fixed to point. Let's simply fix it back here. Okay, let me copy this code again. See. I already said it, I'm kind of lazy, so if I can avoid writing more code and simply copy paste it, I do it. And that's good advice, trust me. And we'll be needing the fixed mouse X and fixed mouse Y alongside with OK. This is useless. So now that I see it, this again is useless. So let's go and delete it. And back to our code. We could actually be telling it X is not X. Instead, we can already compute the delta movement as we do here. So we'll be doing that is X minus equals the fixed mouse X position, and the same goes for Y. So a better time for this function would be get mouse delta, as delta meaning movement done since last check, and yeah, that's completely fine. Now let's implement it on our code. We will declare double X, double Y, 28 buttons. Sorry. And let's get to our values by doing window. Okay, window get mouse delta. And now that's buttons. If left is pressed, we no longer need to apply this X rotation. It's again become useless. Ignore all of this. Fine, that's fine. Okay. Our game HTTP, we no longer use any of this, so we may simply delete them. And I believe that's all. Let's check it works. Left to right. So let's check if it works or not. Oh no, of course. That's, my god. We haven't called this, so it won't work, of course. And we should call it on every update. 60 times per second gives us some good starting point. So let's try it. See, that's fine, It's working. I'm pressing left, I'm pressing now right. So yeah, that works. That's fine. We don't really need left and right now as we're implementing camera movements. And we don't actually want to be pressing any button for the camera to move. But it's nice to know it works. So that's fine for us. So we'll need our camera that's here. We need the current position. No, it's not here. I mean, I got confused now. It's here. We need our camera position, which is already here. And we'll be using, instead of a view reference point, that's what we've been calling now, that's the point we're looking to, we will instead use one direction, the direction of the camera. So let's rename all of this. And let's call this dir. This will be set dir. Okay, of course if we change direction we must change view matrix. So let's go to our camera. Our initial direction will be the same, and instead what we will be doing is setting the observed the position we're looking to as the current position plus our direction. We cannot simply put the direction, as that would be an absolute position. Instead, we're actually telling it our point plus direction, and it makes another point. That's exactly what we are looking to. And okay, that's fine, but that still doesn't give us movement, and we will need to do some calculations for us to get this working. So let's make a method called I don't know, LFS inline void move camera. Oops, sorry, move camera, and it will be taking one angle and one more. That Y and that X stands for 2D coordinates. It will need to convert to 3D coordinates for the camera to work, so we'll be doing some basic transformations, and that will be well, we will need to save these two angles as they are cumulative to the other ones we've already had. So let's simply save them up. We could actually do a vector for it. No, that's an overkill. So let's simply do this. And we'll be doing this angle. And same goes for Y. The reason we do that is, as you know, the mouse is keeping centered on the screen. So if we then use this summation, we would actually be always resting our angle to 0, 0, 0, and we wouldn't move the camera at all. We would always be looking at the same position, so that's how we achieve this movement. And now, we need to declare, nope, nothing. We already declared our vector, and that will be a vex3 that will be done as the, let's say, cosinus of our x angle. I mean y multiplied by the sinus of our x angle. Then again, our sinus of our vertical angle. I don't know if if it would be better to use these functions for cosinus and sinus, but we'll try it like this, and let's see what happens. Oops. And cosinus of... That's basically a way to convert 2D coordinates to 3D coordinates. I have no graphics at the moment to show it, but you could imagine a sphere and these angles, not being really angles, but distance from the center to one point of the sphere. So yeah, we don't need this vector. We assumed it will always be 0, 1, 0, but that's not true when we can move the camera, as we may end up looking downside. So what we need to do is another vector which keeps the verticality and the horizontal line of our camera. So starting with the horizontal line, I think we'll do this right, like this. Okay. Let's declare vector that will actually be the sinus of our horizontal line. You know, if we're talking about horizontals, rotated by an angle of 90 degrees, which is P. I don't know if it's declared somewhere around here. Maybe Jerem has it. P. It seems so. We even have half P, maybe. 0, that's true. We have half P. Is it a call? Well, let's just P. That could be clear. P. I don't actually know if this is a call or what is it complaining about. So it's telling us it has too many. So let's just double for it. And not yet. No. Okay, that's fine. That's fine. I haven't actually worked before with GLM, so problems like that, like this one, may arise from now to then. And same for the set coordinate, that is our angle x minus half p, that's 90 degrees. P is 180 degrees, so half p is 90. And I forgot one parenthesis. That's right. Fine. Our y coordinate stays at 0, because we don't actually want to use any y coordinate. I said this is a horizontal line, and thus its y must become 0 no matter what. And now our vector, a vector, will be the cross product, which is cross of this right and our direction. We no longer need this right vector, so that's why I'm not declaring outside here. We may, for optimization reasons, declare it as one attribute, as a class, but there's no real reason for it, so let's keep it like this. And same goes here. So move camera changes the angle, direction, right, group, and of course, whenever we change any of this, we must recalculate for our view matrix. That's fine. Let's try it. Half P is not a number of. Let's Google it. Let's Google it. We may have to include some file. See here, we have. Yeah. So back to our code. Include here. This the constants, and why not? Yeah. So let's try now. We shouldn't actually be able to use it yet. We don't even have any. We are not looking at anything, and that may be because we're back to our camera. I don't remember what our BRP was originally, but to be able to see anything right now, we should be using this div. Remember, our old BRP was 0, 0, 0, and that's actually the same as getting our observation, which is not 0. That is 1, 1, and summing, as we do here, that minus 1, 1, 0. So using this should get us back to our scene. Yeah, that's it. So we'll still see it. We cannot yet move as no keys has been implemented, so let's go to it. We'll make a method here called LFS inline bool is key pressed, which will take, I don't know what kind of variable uses zlf for keys. I guess it won't be that. It should be 32. I don't know. Let's try it. Key, sorry, and let's implement it. I should actually be writing this here. That's been a mistake. So back here. We'll be using the zlf w get key. That's it. Yeah. Get key window, and I haven't seen the type. Let me check. Oh, why isn't it working? Of course. That's me. An INT. It requires an INT. So let's just use an INT2. I'm redefining all these methods just to get them encapsulated and not exposing the ZLFW API outside this window. As you have seen, we don't really use it anywhere except for the double buffer here, which we should change in a near future. But that's the only way. That's the only place we're using it. So that's the reason for declaring everything. And it takes a window and a key. And let's see what it returns. I didn't read it. Okay, returns the last reported state, which may be zlf press or zlf release, and we're actually looking for zlfw press. That's fine. That's fine. So back to the game. Here. Well, we'd actually use this for movement, for camera rotation. Let's try it. Not this, but this. If x, sure. We will avoid the simple case of y and x being 0. We know we don't really need to change anything if that's 0. I mean, there's no point in changing anything in case we don't actually move. So, and in case something changes, we'll be doing move camera. It's not actually move camera, it's actually rotate camera. That's my fault. It should be rotate camera. Rotate camera, and we will be rotating an angle of x and y. Keep in mind, we may have to adjust this. This is being called 60 times per second, so that's at this very moment not game logic independent. We should be dividing this for, I don't know, the time elapsed, and that is how we would get a constant movement rate, be it 60 FPS, 30 or whatever, but just for test reasons, let's do it like this. Building. So let's try and move around. Nope, camera is not moving, and it should be moving. See? No movement at all. So let's see why. I call rotate camera in case x or y is different of 0. That was my error, but I don't believe that that's what really happened. And calculate view matrix. Actually, we've changed it to use our observation plus our direction and our vertical. So it should be working. Let's check again what might have been wrong. Still no movement. Let's go back to the code. We're on game. This is being called. Let's just print x and y. Long float, long float. That being x and y. Let's see if we are really getting parsed or not. Yeah, we are. So mouse is not the problem, as we see it works. And the problem must be somewhere else. Oh, of course, I mean, yeah. Yeah, we've been calculating the matrix, but we are not sending it to GPU. And we should, as we do it here. We do it, let me check where, on Italize, I think. I don't remember where we're sending the camera, but I'm sure we are. See here. On resize, we are sending the MVP matrix, but we should be sending it to somewhere else. Let's wrap this method, on the camera itself, as that would be simpler than calling this here, here, and here. So let's make a method called first inline void method to GPU, which simply does this. Of course, it requires a program. Let's use, we must include it, still to do it. Program, and that's shader program. And no cameras, that's ourselves. And that's fine. Let's use it here. To GPU program. And we should be doing the same here. Well, I actually think we can do this here, as this is not being done on the main thread. Let's try it, but it will crash. It should crash. See, that's it. We should be doing this on the main thread, not here. Okay. Well, we may not really be calling this on a separate thread. I may have to rethink this logic. Maybe we should call game update on the main thread and then manually calling every other method on another thread. That would be way faster. Yeah, we may be doing that on the near future. We'll keep it like this just right now, not to change many things, but let's get the camera working first and then we'll think about it. I'm coming here just to copy the update method of it's on the object. So I want this. And back to our game. I want to sync the. I don't know how we could do this. Okay, let's. Will this change I set out calling update on the main thread, but again, just for a moment, we'll be doing something that's really wrong. But well, yeah. We'll declare another function called main thread. So it's main thread, and we'll be doing this here. And we'll be calling main thread inside here. And that should work. Again, I have to rethink the logic, and we should actually be using the main thread for updates. And I'm not seeing this turn in any way, unless I'm mistaken. And that's really weird. Let's try and make this turn somehow faster by introducing some constant here. Again, okay, I've called to GPU, but I don't know why I've just deleted the rotate camera method. That's stupid. That rotate camera can be done from another thread. There's no problem. It's the actual GPU that needs to be done from the main thread. So, well, I guess it's working, as we're not seeing anything at all. But I don't know where are we looking to, as to not to be able to see anything, nor why. Just the very same moment enter the game. We should be skipping the first movement. I guess it's the first movement, which is making us go to somewhere else. Let's print it. No, let's instead, let's print it. That will be easier for us. Print XY. I believe this first movement of starting also gets here, yeah. See, it's actually telling us we've done some movement, which we haven't. So let's skip the first one. To how do we do it? Okay. I don't know how to do it so that it doesn't get. Let's do a handle input. Let's call this somewhere around our initializer, somewhere around here. Let's call this here, as we already have a window, and we'll simply be doing this. XY. That will skip the first movement. Yeah, and the very same movement of I move, this gets completely screwed. So I'm of course doing something wrong, but I still have to know what. Let's scale this for. That's actually. Okay, that's actually one tick. Nope, no luck yet. So let's check our camera and let's see if we did anything wrong here. We're using the cosinus of the vertical plus the sinus of the horizontal, that's fine. Sinus of the vertical, cosinus of the vertical. Okay, that's fine. Our right vector is sinus x minus p halves. That's fine too. That's fine here too. And our cross product seems to be fine too. So it seems like our view matrix is being not calculated, and I must check why. Let's print some values here. Or let's breakpoint rather than print. So our vertical vector is kind of wrong. That should not be happening. Our right vector, well, it can make sense, and this also seems to make some sense, but our vertical vector doesn't make any sense at all. No, our vertical vector doesn't make sense at all, so... Oh, see here I'm using this and kex, and it should be the one on our class, not the other one. Let's try again. Oops, sorry, I mean we must recompile. See, now our app vector makes completely sense. That's another history. I've made some big mistakes here, like not initializing angle x and y to 0. It should be 0 when we start, and same goes for this. But well, it seems to be making some sense right now. Let's try again. I've put another breakpoint here, I didn't want to. Well, let me stop debugging. Let me check this out, and let's try again. No, not like that. Oh, see, yes, here. We may be moving way too fast, that's all. But, yeah, that's working fine. See, it's not a smooth movement. That's because it's only being called on our main ticks and not on every FPS draw. We can try to make this smoother by using the interpolate variable we already have. So let's try and make it somehow run smoother. Yeah. Instead, we'd also try to make smaller steps on our. Instead of using here this factor, we may be using some smaller factor, and that may look somehow smoother. I've lost our floor. I don't know where it is. Here. Here it is. Well, not quite there yet. Hey, the mouse would actually help too. So let's hide mouse. Also, hide mouse. Here FW. I don't know how it was. I believe it was set cursor. Cursor? Was it like that? No, it's not that. Set. I don't remember how it was done. No, it's really close. Standing on mode, we only have set input mode. Here it is, yeah. Set input mode. Same as here. Let's somehow change it. Cursor, and let's set it to hidden. Let's try again. Not having a mouse makes us think that things are smoother. Well, default angle being 0, 0 is not correct. Should be some other angle. But yeah, that somehow looks better as we don't have any mouse. You may think it's working better. Okay. Let's try to interpolate movement too. Back to our game. Had our camera rotations here. So we should save that last x and y. We'll make these variables attributes to class, and we'll call them delta x and delta y. Delta x, and delta x, and delta y. And this may be moved this row to You know, we could actually do this, but that's duplicating our code. So instead of having our code duplicated around, we'll be creating another method called, I don't know, to update camera maybe. Update camera. But here, let's put it here. Let's again update camera, which will be doing this. That's fine. And we'll be calling it here. And here. So this is not completely true. We don't need this sync whenever we're calling from draw. So instead we'll be passing a boolean called main rather, which will be false by default. And we'll be using that. We can't write this here. I instead comment it out so that I know that it defaults to false, but it would be as correct as simply writing this. That's personal taste. So if not on main, we'll be doing the sync, or instead we'll be simply calling. Let's try it. See, that looks smoother. It actually seems like it's now going faster. There's no such lag. So yeah. Here we go. What else do we need? We also need, of course, whenever I switch from window, this looks awful, so let's try not to switch a lot. And now we need to also handle mouse movement. I'll be using the keys WSD as most games do. We could of course make this configurable, but well, just for now we'll do it like this. Okay, let's use our window method is keyPressed. And as I said, I don't like using GLF constants outside. That's why we have this mouse left button. So we'll be doing something kind of like with keys. Click keys, and let's have. We'll need WASD right now, so let's keep it like this. That will be GLF W key W, and same goes for the other ones. So yeah, there's no need for this padding. WASD. Again, and that's not to expose GLFW outside of where it should be used. So, back here, is keyPressed, keys W. If our key is pressed, we'll make the camera advanced on the direction wherever it is looking to. So, we'll be actually doing. We should do a method for it, I believe. Yeah, we should actually be doing a method for it. So let's simply use WSD, and let's go to camera, and let's make a method called LFS inline with move camera, which will take, I don't know, maybe X3 called axis, and we'll be using our observation point will be our current observator plus our direction multiplied by our axis. I don't actually know if this is the way to do it. Let's try it. So that's fine. Well, I said let's try it, but I didn't call it. So that makes no sense. Calculate view matrix again. And we should actually be our perspective matrix. No, that's fine. Okay, that's fine. So vector code game here. Let's call camera and let's use it here. Like 3 and let's use. That's not actually. Yeah, that's not. Let's check what happens. Again, my initial angle is wrong, and I have to fix it. Oh, I'm moving way too much, and not even where I want to move to. Oh, more solar flow. Okay. Let's go back. So, we should actually be moving the camera. Where's it? Move camera. So, I of course did this wrong. Our camera should be moving like this, multiplied by the width before. Let's try. Again, my initial angles are wrong. Should have to figure them out. Are we actually moving? Nope, we are not even moving. Or at least I don't think so. No, it doesn't seem like we are moving. So, go back to our camera. Let's simply do this like this. I mean, our B direction should not be dependent on our, and my angle is wrong here. No movement at all, and that bothers me. Of course, I mean, we are not sending to GPU all these changes. The same happened before. It's our problem. That to GPU here and that to GPU here should be only called once. Be it one or the other, it doesn't matter which of them, but it should only be called once, as to avoid having too much pressure. So, how may we do it? Let's move this here, let's say, or moved, camera moved. And let's declare this right here. Full camera moved equals, no equals. Up here again. And this would make our camera moved equal. Just in case, we'll always set it to false before anything. And let's try. So let's put it. Well, I'm not moving as I should, but I'm moving, so well, that's something. Let's try again. And direction is not being taken into account, that's why I did the initial multiplication here. Our camera, and that later on I removed and shouldn't have been removed. So we'll take into account direction and let's check again. Oh, of course, I wasn't. No, it more or less makes sense now, it doesn't. No, we're moving, that's right. But we should be moving to wherever we're facing to, and not to somewhere else. I mean, if I look here, that's fine, but whenever I look somewhere else, oh, of course, what this is doing is literally making us go slower as our component or X component is lower. So that's not what I truly want to do. I instead want to move alongside this direction, and that might be done. A cross product, let's try it. No, that won't actually get us anywhere. But for the sake of trying, let's try it. So, okay. Click here. Where's our floor here? Okay, fine. Nope, it's not moving to where it should be. Almost. But not quite there yet. Nope, not quite there. But almost there. So let's see what's wrong. I mean, look at like this will of course move to wherever we're moving towards we are pointing to, and way too faster by the way. So fast that I've even lost our floor. And I was looking at it from downside. So we are not moving, but too faster. But that's something. So instead, we'll be using this as 1, 1, and 1. Now we'll be moving, yeah, now this will work. See, now it works. Okay, that's fine. We finally got movement working. And that's completely fine. So we can move straight. Now we still have to move. This is of course something that shouldn't be happening. We'll work into it and we'll make this not work. So fine. Let's implement the easy case is the S key. Yes, that's of course simply getting this and hitting it. There's some other case. W and S can't be pressed at the same time, or shouldn't be pressed at the same time, that makes no sense. So we may assume this is fine. And let's instead, we're interpolating, so let's interpolate as we should. Let's use a ZLM Vec3 camera movement. And whenever we move, we'll set this camera movement as this. And the same goes here. And we'll be doing the same for A. Remember, what A does is move on the left, so that should be... We're not taking into account the X coordinate, I believe this is true. And D grows to the positive side of the axis, so it should be like this. Or at least I think so. Using it like this will mean that whenever I press W, I can press A, so I can do diagonal moves. We may elaborate this later and make diagonal moves work, but just now, let's assume only one key may be pressed at any time. So, if camera moved, that's here, we'll be doing again. This is kind of redundant, but again, we may change it later. If camera moved, we'll do camera, move camera, and axis will be camera movement. Yeah, that's it. Let's try it. W still, sorry. Our initial angle, as I said, it's not correct. W works, D does not work, nor does A, and S works. So, well, as I said, the easy case was S. And D is actually not working, it's doing some diagonal move to the right? No. Inside, so it's moving down the y-axis, and it shouldn't be. Let's see, what did we do here? Okay. If we press D, no, we should only be moving left and right. But although we are, that's actually slower than the other movements, I mean. So why don't we also move straight, and let's try to move straight. So nope, that's definitely not what we should be doing. Okay, I've lost myself here. D and A is not doing what they should, but well, we're at least moving, and that's some good point. Okay, let's see.
Everything I touch.
How should we make it so that we move on right and left?
Can't help but fall in love.
We try something. Of course, making this will make straight and back not work, but let's just try it for right and left. Almost done it. And okay, where's the name here?
So I'll say,
No, I think we tried this before.
don't take me.
What am I? No, it's not really. Of course, that means we are calculating the normal, the cross product giving us. No, that's true. The cross product gives us a perpendicular line to our plane, and that's of course what we don't want to. So I may be overcomplicating it, and it shouldn't be that hard to do. Okay, let's try. moving to the right would be the same as using our direction and rotating it 90 degrees. So let's try something. Just try it. Let's make here instead a rotation of. Let's make it. Yeah, let's try it. I don't know if this will work, but half. Yeah, I don't know if I have here access to this variable. I bet I can't do this as I don't have it included here. Let's try it. Where did I write it? Let me check. On D. Okay, let me press D. No, that's moving as thread. That won't work, of course. Okay, I don't really know. I have to look for it somewhere. Let me think. Okay, our camera to move to the right. The same as telling to move instead of this direction. Okay, I'm kind of lost here, as you can see. Okay, I don't know how to get it to work. Okay, sorry. Let's try and see. Move camera to the right. No, that's MATLAB, of course not. No, instead let's make change vector. See, it's actually in the cross vector, so we weren't that far away from it. Oh, but we thought already got the right vector on the camera. We're kind of doing some. That should be way easier using our right vector here. Let's try it. I should fix the angles. I really should fix them. So yeah, that was way easier. We really got them. My bad. That was me overcomplicating things for no reason at all. So yeah. That actually should be called I don't know, speed. And we should have one more parameter called GLM vector axis. Now that makes more sense, and we should be using our axis the 0, that's movement along x, to multiply or direction, and to our axis Z to multiply to our right vector. So if we do this like, if you call it like this, camera movement, do it one more variable now, camera movement direction, camera speed. Okay, that should be constant, but we'll define it like this. This will always be constant, so there's no reason for doing it here. Let's move that here. And let's make it like this. Okay, that's fine. Camera speed is set up. No, that won't work. That will work, sorry. Again, that's me. Camera movement here should be a ZLM vec3 with 1, 0, 0. Here it should be -1, 0, 0. Here 0, 0, -1. And here positive. And that should be all of it. So yeah, that should be it. Let's search for a floor here. Moving right, moving left, moving front, moving back. So it's working. We finally got our camera fully working. We may want to do some diagonal moves, and that's not hard now. We may simply combine the old camera movement, so that should be actually summing and summing, and that should be, in case we haven't done anything, camera movement should be set to 0, 0, 0. Let's try it. Okay, front, diagonal, back diagonal. Yeah, that's nice. That's nice. See? I'm now moving diagonal. So yeah, it's working. Nice. That's some pretty logic I've got here. And okay. This camera speed I've defined here, which is dependent of the game logic I mean. That should be configurable depending on our scheduler, instead of being a constant value. So let's try and set it up. Okay. No, let's leave it like here, like this. And I think that's all I wanted to today. I actually ended up faster than I wanted to. That's it, yeah. That's fine. Next day, I don't know if I'll be doing textures or I'll be doing some physics. Whichever I think should come first, maybe physics. I don't know. We'll work into it. So, if you want to ask something, or that's now when you should do it. Oh, now, before going, I'll implement a space to go up. Yeah, that could be interesting. Let's go to window, let's define here, space equals. Okay, and let's make if window whiskey pressed space. We will actually be applying camera movement. VLMPEG3 along this Z axis. I found something wrong here, that's movement. And on our camera, the date here, we should also be taking into account that whenever we will using plus axis 1 multiplied by the cross product, well, there's no need for this for our poop. That should be enough. Our poop is already the cross product between right and dir, so that should be way more than enough. Let's try it. That's fine. See, I'm going up right now. Okay, I'm going up right now. Up and front, up and back. So you don't see it. I'm actually going back. See? So yeah. And maybe we could use shift as the button to go. Okay, wait and shift as the button to go down sides. So let's use it too. Shift. No shift here. No shift here, so that may be a right shift. Okay, no, left shift. I want left shift. Left shift. Okay. So again, there's no reason for us to press up and shift at the same time. So up, we have preferences. That's the first one coming into the if. And that will be the very same operation, but using a -1 here. Again, let's check just in case it doesn't work. Initial angle. Yeah, it's working. Okay, that's fine. Yeah. I'm way more happy than what I thought I'd be by implementing this camera. Still no collisions. A camera should be checking collisions and not allow us to do this. But well, we'll work on it next day, maybe. Okay. So, well, yeah, if anyone wants to ask something, otherwise I'll be leaving now. Let's commit this to Git. Sorry. Let's add, oops, sorry, here, let's add everything here. Session 5 camera movement and input. There's no need for the push, but I do it. Session 5 again. Camera movement and input. So that's it for today. Thank you for watching me, and as you always know, follow me, you follow me on Twitter, on YouTube, wherever you want. So thank you.